let's take a look at example 8. Let f of x equal power series formed by x to the n over n factorial, and we want to find the interval of convergence of the original function, the derivative of that function, and the antiderivative of the function. So we know that this as a power series, it is both differentiable and continuous, so we can also take the antiderivative either term by term or pardon me, or on the generic nth term. Let's start that process by maybe just expanding this thing out just a little bit. So f of x equals summation n equals 0 to infinity x to the n over n factorial. If I were to stick in a 0 here, I have x to the 0 power, 1 over 0 factorial, which is 1, so we have a 1, plus plug in a 1 here, x to the first over first factorial, x plus, plug in a, let's see, we plug in a 2, x squared over 2 factorial. Not supposed to be a dot there. X to the third over 3 factorial, and then so on, right? All right, so plus x to the n over n factorial, and then we'll keep going. All right, now, in order to find the interval of convergence, we must perform the ratio test. Limit n goes to infinity. Absolute value of n plus 1th term, n plus 1 factorial, divided by the nth term, so I'll have to multiply by the reciprocal, n factorial over x to the nth power, and cancellation crayon, get it out. Okay, so remember that n plus 1 factorial can be rewritten as n plus 1 times n factorial, which will cancel out here. And then as far as the x's go, you can subtract your exponents. You have n plus 1 minus n. The n's will cancel, and you're just going to be left with x to the first power on the top. So this is equal to the limit. As n goes to infinity of the absolute value of x is the only thing left inside the absolute value brackets because we can pull the n plus 1 out. It's positive. All right, so the variable for the limit is just the n. Absolute value of x is not affected, so this bottom is going to infinity. So something divided by this infinity is equal to 0 no matter what, which of course is less than 1 for all real numbers. Doesn't matter what you plug in there for x, which means that our interval of convergence is all real numbers. And its radius of convergence, of course, is infinity. That's interesting. All right, we're done with that guy. Let's go ahead and take the derivative. So f prime of x should be equal to our summation from, well, hey, remember when we take the derivative of this first guy here, it's going to go to 0. It's going to disappear. So that's going to start at 1 instead. N equals 1 to infinity. And we'll just take it on the generic term. If I were to take the derivative of this, I leapfrog the power down. So n times x to the n minus 1 power, and then you still have n plus 1. No, you don't. N plus 1 factorial. You just have n factorial on the bottom. Okay. And you can do this like term by term, of course. Take the derivative of the 1. It's a 0. I'm not going to write it down. And then the derivative of x is just 1. Derivative of the x squared over 2 factorial. Remember, 2 factorial is just 2. So this 2 would leapfrog down there and cancel out with the 2 factorial, right? So it is 2x over 2 factorial. 2 factorial is just 2, so it cancels out, and you just get x back. Whoa! Random alarm. Okay, plus, and then the same thing is going to happen here. You're going to have leapfrog that 3 down, x squared over 3 factorial, but that's 3 times 2, and those would cancel. And so you have just x squared over 2, which is the same thing as 2 factorial. Okay, and then if we were to take the one for the 4th term, which I didn't write down, if you leapfrog your 4 down, x to the 3rd over This is supposed to be 4 factorial, which is 4 times 3 factorial, and your 4's cancel. Is this looking familiar? Doesn't it look exactly like our original function? So I wonder what function. When you take its derivative, it's exactly the same. Now, also, this means that you could rewrite this index. You could essentially just translate the whole thing to the left 1 unit. But before I do, I'm going to fix this n over n factorial because, it's both the same variable. It's n. So here, just like right underneath here, n over n factorial, you can rewrite n factorial as n times n minus 1 factorial, and then your n's cancel. So I'm going to rewrite that guy after I scribble stuff. Okay, rewrite this as, come on, disappear here. So this way the power and the factorial there, they exactly match up. And then if you wanted to, you could translate that whole thing like your index to the left one, n plus, not n plus 1, n equals 0 to infinity. And then if I translate this thing to the left one, I would add 1 to each one of these exponents. You would have x to the nth power, and then n minus 1 plus 1 is n factorial, and you can definitely see it's exactly the same. You can see if you were to start in here with your 0 here, x to the 0 power is 1 over 0 factorial. It's that term. Wow. Okay. So if I did perform my ratio test on the original thing, not on this one, let's see if that affects anything. So the limit as n goes to infinity, absolute value of x to the n minus 1 plus 1, or x plus blah, blah, blah. Back that up. X to the n plus 1 minus 1 is just x to the nth power over n plus 1 minus 1 factorial, which is n factorial. And then multiply by the reciprocal there, so n minus 1 factorial over, and then x to the n minus 1. All right, yes, there we go. And then cancellation here. So this n factorial is n times n minus 1 factorial, which cancels out right there. And then if you have n minus 1, you have n minus n plus 1. So you have an x to the first power up top. The limit is not identical to what we had before, but it's very similar. N goes to infinity. We have absolute value of x over, we're just left with a factor of n. Doesn't really matter because that's going to go to infinity. So this is equal to 0, which is less than 1. And its interval, once again, is all real numbers. Hey, should we check the endpoints on that? Calculus joke. Anyway, so do I have enough room for the antiderivative? Probably not. Let's go ahead and add next page. Boop, boop, boop. Just in case it goes long, because it's probably gonna. All right, so now we're going to take our antiderivative of f of x with respect to x. Okay, so that should be equal to, let's just take the antiderivative of this original generic term here. So it'll still start at n equals 0. If I take the antiderivative of this, I'm going to add 1 to the exponent and then divide by that same exponent. So it will look like summation from n equals 0 to infinity of x to the n plus 1 power. And we'll divide that by n plus 1 times the n factorial that we started with. And tell me, what is n plus 1 times n factorial? That is an n plus 1 factorial. And then you have your plus c, but we don't like to write the plus c right there, so let me get rid of that guy. And scooch it over and put it up front, c plus. There we go. All right. So, let's find the interval and radius of convergence here. Oh, also, yeah, if you were to take the antiderivative of these guys, term by term, this one here, whoa, whichever that is, we take this one, that would be an x. This is going to be an x squared over 2. This will be an x to the third over 3 times 2 factorial, which is 3 factorial. This would be x to the fourth over 4 times 3 factorial, which is 4 factorial. It's identical to this one, but you don't have the 1 that's right there. Instead, you have a plus c. I wonder what the plus c would turn out to be. All right. So interval of convergence, we'll take the limit as n goes to infinity. Just one more time. Only one more time. Just bear with me. We have x to the n plus 1 plus 1, n plus 2 power over n plus 1 plus 1, which makes it n plus 2 factorial, and then multiply by the reciprocal there. X, that's an x. Okay, all right, and then red crayon. N plus 2 factorial is n plus 2 times n plus 1 factorial. Those cancel. And then we have an n plus 2 power minus an n plus 1 power. The 2 minus 1 gives us the first power, which is equal to the limit as n goes to infinity. We're just left with an absolute value of x up top, and on the bottom we have an n plus 2. It's very similar to what we had before, just slightly different denominator, which still doesn't matter because this is going to go to 0, which is less than 1, and its interval of convergence is still all real numbers. This is interesting. So have you pieced together what this function could possibly be, whose derivative is exactly the same as the original function and whose antiderivative it seemed to be the exact same thing with it? We had this plus c here, but if we had an initial condition, if we knew what this function was, we could probably solve for that plus c.